This is my notebook machine. I'm currently processing video for YouTube. Recently, this is my new desktop machine. I designed this machine and assembled all by myself. It has i-Core 9, the CPU. It has 32 gigabytes of RAM and 1 gigabyte of SSD. It's pretty fast. I have been using this notebook almost 8 years so far, and I can still use it. The reason I made this new desktop is because of this tablet. When I tried this tablet with my notebook was too slow to express mathematical formulas on screen. I can try now. I can express math on PC screen. The sole reason I made this desktop machine is to use this digitizer and express mathematical ideas on YouTube. My first notebook is IBM ThinkPad back in 1998. While I was working for IBM offered half the price. At those early days of notebook machines, the price of ThinkPad was about 7,000 US dollar, 7 grand. As an IBM employee, they offered me half the price. After IBM ThinkPad, I used compact notebooks. Then I moved to HP. Then I moved to MSI notebooks. So this is MSI notebook. And this is also MSI notebooks. I have used these machines for a while, almost 8 years for now. Now I am going back to desktop. After 20 years, I am moving from notebook to desktop. In combinatorics, we learned the following formula. NCR equals n-1 CR-1 plus n-1 CR. If you are from North America, you probably learned like this. NR equals n-1 R-1 plus n-1 R. This formula is called the number of combinations or binomial coefficient. This formula plays an important role for enumeration of subsets. In computational aspects, this formula is inefficient, but this formula enables us to solve a lot of problems. Memorizing this formula is useless. What really matters is understanding what this formula means. So, we have to understand the meaning of this formula. If you understand the meaning of this formula, You don't need to remember. You already know. But if you don't understand the meaning of this formula, first you cannot remember this formula and you cannot use this formula. Now let's think about what it means. NCR means how many different or distinct ways can we choose are distinct elements out of a set with n elements without repetition. For example, if we are given a set with 4 elements, set S has 4 distinct elements, 1, 2, 3, 4. For C0 means from the set S has 4 elements, 1, 2, 3, 4. We are choosing 0 elements. Then we can make only one set, empty set. Okay? This is also denoted by phi. It is called P or pi, P. Now let's think about this. For C1, so there is only one set. So this number becomes 1. Now let's think about this case. From the set with the 4 elements, we are choosing 1. How many different ways can we make subsets? 1, 2, 3, 4. So we can choose 1, 2, 3, 4 different ways. So we can make 4 different ways. So the value becomes 4. Now let's think about this. 4, C, 4. So from a set with 4 elements, we are choosing 4 elements, 4 distinct elements without repetition. How many different ways? There is only one way. We choose all elements. 2, 3, 4. So there is only one way. It's 1. Now let's think about this formula. N CR equal N minus 1 C R minus 1 plus N minus 1 C R. When a set S is given that has 4 elements, 1, 2, 3, 4, and suppose 4, C3, then it becomes 3, C2 plus 3, C3. Okay? For the time being, don't concern about this part. Just concentrate this part and this part. After considering about this part on the right hand side of the equal, we'll consider on the left hand side. This is set S. Initially, choose any element. You can choose any element. For example, we will choose number 4. We can choose any element. So I save number 4 here and I form S prime. S prime, since we have chosen number 4, we remove this element and form new set 1, 2, 3. Now it makes sense. From a set with 3 elements, we choose 2 elements. From a set with 3 elements, we choose 3 elements. So S prime has 3 elements now. Now let's consider about this part. We are choosing 2 elements. We first choose 2 elements like this. 1, 2 elements. We have chosen 2 elements. Now from this set again, we are choosing 2 elements. 1, 3. Now 1, 3. We have chosen 2 elements. Now from this set, we choose 2 elements. 2, 3. Then 2, 3. Is there more way? No, there is no more ways. Okay? Now let's consider about this part. This part, from a set of 3 elements, we are selecting 3 elements. So there is only one way. 1, 2, 3. Okay? Now let's see on the right hand side. From the set with 4 elements, we are choosing 3 elements. From a set with 4 elements, we are choosing 3 elements. In this case, we have only 2 elements. Okay? In this case, we have 3 elements. When we start, we chose 4. Now we move this element. From this set, we put here, like this. 4, 4, 4. Okay? Now let's see this equation once again. 3, 2, 3, 3. Here, we don't need to concern about this number. We only count 1, 2, 3. So this is 3. 3 sets. Plus 3 from the set with 3 elements. We are choosing 3 elements. There is only one way. So 1. This 1 comes from here. This 3 comes from 1 to 3 from here. The total is 4. This is on the right hand side. This value on the right hand side of this equation. Okay? Now let's consider about this side. Now on the right hand side, from this original set 1, 2, 3, 4, we are selecting 3 elements like this. First, 1, 2, 3. We have chosen 3 elements out of a set with 4 elements. This is the first set. The second set, we choose 1, 2, 4. 1, 2, 4. Now from this set, we choose 1, 3, 4. From this set, we choose 2, 3, 4. 2, 3, 4. Okay? 1, 2, 3, 4. So for C3, we can choose 3 distinct elements out of a set with 4 elements. 1, 2, 3, 4. 4 different ways. Now, this number is 4C3. This number is on the right hand side. They are exactly the same. Please note that this set 1, 2, 3, 1, 2, 3 are exactly the same. 2, 3, 4, this set 1, 2, 4, this set are exactly the same. 1, 3, 4, this set 1, 3, 4, exactly the same. 2, 3, 4, this set 2, 3, 4, this set exactly the same. So left hand side is equal to right hand side. Now let's try once again. Let's think about this. 4, C, 2. So we have set S with 4 elements. 1, 2, 3, 4 elements. Okay? From this original set, we select S prime equal 1, 2, 3. We removed this element 4. Now we have a set with 3 elements. From this set, we have a set with 3 elements. We choose 1 element from this set, a set with 3 elements. We choose 2 elements, like this. Then here, from this set, we choose 1 element, so it can be 1, 2, 3. Okay? We completed this part. Now we complete this part. From a set with 3 elements, 1, 2, 3, we choose 2 elements, like this. 1, 2, 1, 3, 2, 3. Okay? Since we originally have to select 2 elements, we put this element here. So we plus 1 more element. This 1 means this 1 element. Okay? Then it becomes 4, 4, 4. This part 1, 2, 3, so 3 different ways, plus 1, 2, 3, 3, it becomes total 6. Now let's collect this set. 1, 4, 1, 4, 2, 4, 2, 4, 3, 4, 3, 4. 1, 2, 1, 2, 1, 3, 1, 3, 2, 3, 2, 3. Okay? So 1, 2, 3, 4, 5, 6. Now let's think about this part. Okay? So from original set 1, 2, 3, 4, 1, 2, 1, 2, 1, 3, 1, 3, 1, 4, 1, 4. Is there any more ways? These are all. Now let's start 2, 1. 1, 2 is already selected. 2, 3. So 2, 3. 2, 4. 2, 4. Now let's think about 3. 3, 1. Already chosen. 3, 2. Already chosen. 3, 4. 3, 4. 1, 2, 3, 4, 5, 6. So 6 different ways. So 6 different ways on the left hand side. On the right hand side, also 6 different ways. Now let's compare 1, 2, 1, 2, 1, 3, 1, 3, 1, 4, 1, 4, 2, 3, 2, 3, 2, 4, 2, 4, 3, 4, 3, 4. Okay? Please remember this procedure. Then we can say like this. Now let's see once again. NCR. We first remove one element. Now we have n-1 elements. Okay? So n-1 elements. We choose r-1 elements because we will plus 1 here. We will plus 1 element here. We choose r-1 elements plus from n-1 elements because we removed 1 elements. From n-1 elements, we choose r elements. Please note that this -1 and -1. When set S with 1, 2, 3, n-1, n elements are given. Originally this set, we form S prime 1, 2, n-1. We stash n 1 element. We stash n 1 element from this set n-1, a set with n-1. We select r-1 because we will add 1 element later here. Okay? Because we will add 1 element here, we select r-1 element. Plus, from this n-1 element, a set with n-1 element from this set, n-1, we select r element. So this is NCR. Understanding this concept is important. If you memorize NCR equal n-1 CR-1, then imagine like this. Plus, we will add element n here. 1 element. Okay? This is 1 element here. Then from n minus 1 again, from this set S prime n minus 1, we choose R element. Okay, this part is this set, this part is this part, and this amounts to this. If you memorize NCR equal n minus 1 CR minus 1 plus n minus 1 CR, or NR equals n minus 1 R minus 1 plus n minus 1 R V minus 1, because we will plus last element. Okay, we will put this element here, so it becomes minus 1 plus 1 element. This element is this n, so it is R element. It is R element. If you try to memorize this equation without understanding its meaning, without understanding what it means, this formula is useless. Without understanding the meaning of this formula, first, you cannot remember it. Second, you cannot use it to solve your problems.